All right, guys, we're about to start, so if you're hanging out in the back, take a seat. This is the rather unusual for us. We kind of do panels. We rarely did Fireside chats. Last time we did them during the happy hour, and everybody was drinking, so we didn't get as many people. We actually employed an accordion. Accordion is with a conga line to lead people back. So now we decided we'll do it a little bit earlier. So thanks for being with us here.
Good to be here. Hi, everybody.
So this is Richard Socher. He's the chief scientist of Salesforce. He is a big friend of By the Bay conferences. He started at Text by the Bay in 2015 at MetaMind, and he was a data by the Bay. And I think in between, basically, there was a story where multiple companies were doing data by the Bay, at least two that bought by Salesforce. So it's a very good thing, you know, if you submit talks to By the Bay events, you get bought by Salesforce. It's a tradition now. So I encourage that. And so I think it's really fitting, right? What we did this year and last year, we brought a lot of topics from data to scale by the Bay. So this used to be a software engineering conference, but now with machine learning at the end of data pipelines and AI, right? Basically, machine learning is now called AI. We have essentially, with connection. So Carlos Gesterin said that every application is a machine learning application, right? So he was saying it for a while. Now it really happened. So Richard, I think, is a great example of kind of cutting-edge industry going into cutting-edge academia going into industry, and I think it's really interesting how this happens. So Richard, maybe you tell us a little bit about your career. What you were doing at Stanford at MetaMind, and how you went to Salesforce and where you now.
All right, well, whole career. All right, so I guess I'm originally from Germany. I came to the US for my PhD, and then thought I was going to become a professor. Actually accepted a faculty job after I finished my PhD, but then thought, well, maybe for 1 year I will do this startup, and then maybe I can transition and become a full-time professor. And then, of course, in 1 year, not much happens in a startup, and really, I had the team at that point, and I really couldn't leave the team. And I was also realizing that you can do some amount of research in AI in a startup, though I think probably not for more than a year or so. Then you really need to mostly focus on product and customers and sales. But I was also then starting to teach at Stanford, and I loved it for 3 months of the year, but I don't know if I would have wanted to do it 9 months of the year. It's a lot of work, and not all of that scales in terms of student interactions. And so, long story short, stayed at MetaMind, and then in 2016 we got acquired by Salesforce, and it's a really good combination, because in order to make successful AI products and actually be sustainable in AI, you need to have three things. You need to have data, good algorithms, and an understanding of the workflow of how you actually incorporate those AI algorithms. How do you actually change how people do their work or do whatever else they do? And so in MetaMind, my startup, we had some of the best algorithms, but really as a small startup and with a very academic team, it was hard to get companies to give us the data and then help them label it and so on. And now I guess we're a little bit ahead of our time, just like others, in terms of labeling the data. There are a lot of startups now that just label the data for you, and they're focused on maybe just self-driving cars and helping companies label across different modalities for self-driving cars, or working on just medical image labeling and things like that. And then the third thing, you need to really, at this point, I think the time is over for building general purpose AI startups, and you really need to be laser focused on a specific vertical, really understand if you want to change the way service works, you want to build a chatbot that automatically gives answers to service requests, you need to be hyper focused on just that, just chatbots, just for the financial industry, banking or something like that, and help people recover their passwords for their banking accounts and find out how they change or open a new account or something like that. And that was kind of what Salesforce is really good at, because we run sales service marketing and have huge scale in that. And we, of course, also have the Salesforce to actually get that out the door. So it's a perfect combination of the algorithms being put in the right place.
Nice. So what was the kind of best change going from academia to industry, and what was the worst change?
That's an interesting question. So I think I think the scale, actually, as we're right with the theme, the scale that you can have in industry is just unprecedented. As a best case scenario, as a professor, you may have 10, 15 PhD students, and beyond that, you're really just a bad advisor because you're not giving them the amount of advice that they really need. So you can't really ever scale, and then of course you can't get the stuff into production. So when you think about how do I have the most impact in life, with, in my case, artificial intelligence that I'm really excited about, I really want to push the state of the art forward and do academic research, but then I also want to see, ideally, the impact more quickly in real products. And I think AI, and I don't think that's too hypey, AI will change pretty much every single industry out there. And it's just a matter of having the right data sets. You know, if it's agriculture, medicine, CRM, like banking, like everything will get changed with AI. And so it's just important to think about how to do it. So basically, what I'm most excited about right now is that AI is in this interesting time where you can actually do fundamental research in companies. And we see that the bigger companies get, if you're a small startup, you can't do it for too long, right? You can only think so far before your funding runs out, or you really need to think about scales of sales. But once companies get bigger and they start thinking about a 3 to 5 year horizon of, you know, do we still exist and are we going to get disrupted by other players? And when they start thinking longer term, then they start having research groups, and then you can actually do fundamental research in industry. And that's the case certainly for AI right now. And that's why it's so exciting to be there. And then having like really great engineers to collaborate with and get those products out the door is really fulfilling.
So yeah, I found, you know, you guys really regularly publish, and you're on the cutting edge of deep learning research itself, right? And so I'm really curious. So it's not often, you know, that the research lab in a big company has the autonomy, because, you know, there are companies like IBM who are used to run research centers, but Salesforce is not known for doing that, right? So I'm curious, how did you manage to keep this balance, and was it kind of the will from the top, kind of to do it this way? Did you have to fight for it? How do you manage to kind of do both things, you know, advance the frontier of AI and also productize good AI?
I think it has to come from the very top of the company. I think you have to have buy-in from the CEO, and then ideally also, you know, the CTO, and in our case, our two co-founders, Parker Harris and Mark Benioff, and then Srini, who runs all of technology. So once you have that, but then it's a new muscle, and a lot of companies don't have that muscle yet, and only some of the really large companies like Google, Amazon, and so on really have it, and have it flexed enough to really know how to use it. And so the way I tried to go about it is that I knew that if I just did pure research and just published a bunch of amazing NIPS and ICML papers, like I would probably not be able to grow to hundreds and hundreds of like pure researchers. And so I try to make sure from the get-go that we have some people who are really excited about just pure research, but then we also have some people who are naturally, personally excited about applied research and actually AI engineering in the group. And as long as both of them do their jobs, you can grow together. And then we actually have a couple of different ways we interact with the company. And to be honest, I don't think we have it fully figured out for all eternity, but there are sort of 4 different ways that I think make sense for a research group to interact with the rest of a company, and we're kind of doing all 4. So the first one is we just give advice. People know already, they know how to run a model, how to actually have something in production, but it's, you know, 65 or 70% accurate, and they really want to be 90% accurate. And I've had some amazing collaborations with sales teams and Alexis there and others where that worked out really well because they were already quite advanced. But then we also have some folks who couldn't really take the advice and implement it themselves because they don't know all the papers and they don't have the background. And so for them, we actually sometimes also send them code. We train a model, and especially for sort of prototypes and A/B testing and quick iterations in the beginning, you can just have the model trained already and just say, here's the prediction or testing code. So not testing in the sense of, you know, unit tests, but testing in terms of machine learning testing. So predictions. And then the third thing is we try to build APIs. Because once you do the first 2 a couple times, you realize, okay, well, we've given this advice to that group, and now we've given the same advice to the other group. And that doesn't scale because we have like 33,000 employees and thousands of engineers. And so And likewise, if you just send them code, some people might ask for similar code, and you're like, now they're building a running infrastructure for that code, and the other group's building the same kind of infrastructure running similarly. So then you start to see the synergies after doing this for a while, and then you want to create APIs. And I think the API model is quite powerful because we see a lot of synergies between different groups. Like we want to do, for instance, sequence tagging, trying to extract dates and times and names and company names from text. And it turns out that's super useful for chatbots, that's super useful in sales emails, and that's super useful on social media and in a lot of other places. And so once you have one API that's really powerful in general, then it can be used across a whole host of different applications. And then the fourth one is actually when we create a completely new kind of product, which it turns out if you have a large company, it's actually kind of fun because there's very little friction with anybody else because it's a new product line. Nobody says, oh, but we were working already on this product, why are you doing this? So one of those new kinds of product lines that came out of research was Einstein Voice Assistant, where you can just walk out of a sales meeting or any kind of meeting in the future and dictate what happened. You're like, oh, I just had a meeting with Acme Corporation. We should create a follow-up with their VP of Engineering in 2 weeks and maybe upgrade this opportunity to be like $500,000. And then you just say that, and then we do voice recognition, natural language processing, sequence tagging, and things like that. And then we also have a deep connection to the database of all the customer data, and we can update that entire field of the CRM. And that's a super powerful new application. Basically, the least fun part of using most enterprise software is data entry, and you make that data entry super easy for people. So those are kind of the 4 different ways: code, APIs, advice, and new product lines.
Nice. So I want to recognize Alexis Roos, who gave the talk this morning with his colleague. So here, if you've seen this talk, it was great, right? So and so I just want to pick up right on. So that's a problem which we can all understand. Kind of you have the contact graph and you have an entity, and you want to recognize is this the same person or not. And I understand that you have a protocol email insights, right? Which it's using. Can you talk a little bit about how that kind of collaboration goes?
Sure, yeah. So Alexis was actually a great example of where we gave advice because they already knew a lot of things that they wanted to do and they knew how to do them. But maybe they're all using. Of course, if you're doing natural language processing at this point, you would be using neural networks of a sort. But then neural networks have a lot of different knobs to tune, and you can get a model that works reasonably well, like an LSTM. But then when you have a research team that's really looked at LSTMs in like all the gory details and all the various knobs and whistles and bows and whistles that you can tune on them, you realize like maybe you need bidirectionality, you can have various kinds of dropout, and I don't want to go too technical, but there's a ton of different ways you can basically make it harder for the model to do well during training. You can delete certain weights, you can delete certain activations as the neural network is going over text. You can delete certain words. You can have certain deletion masks that you keep replicating. There are a ton of variants, like at least 10 different ways you can do dropout on recurrent neural network sequence models. And then there are wholly completely new kinds of sequence models, like quasi-recurrent neural networks that are much faster, parallelizable in GPUs and things like that we've developed in our research group. And we basically are able to work with them and evaluate a bunch of different kinds of sequence models and help them improve their accuracy by like 20%. So that was a super fun collaboration where everybody sort of came out and felt more empowered to use deep learning.
So this sounds, it's like an engineer's dream, right? Because I remember, I kind of fall more on an engineer side when it gets to systems. So my favorite algorithms basically is take a huge array, sort it, and take top 10. Right? It usually works. You just need to know what to sort on. And so, and so let's say you're kind of classic engineer and you're tasked with doing something like NLP, right? So kind of, your normal mode of operation is, as opposed to a scientist, right? Like you don't look at the top research, you see what open source is available, how quickly I can steal it, is it, building, right? Can you plug it in, is it fast? So what normally happens, like you take Cerealm, or like some existing like ngram package, so you do basic common sense, right? And usually it will work. And so what forever remains unanswered is, could it have worked better? Right, and so in your case, I think it's a unique resource that engineers can come to you, and you basically know what's going on in NLP, and you know what state of the art. So I'm wondering, right? So do like several, like more folks like Alexis come to you, do they already have like their home cooked NLP set up, and are you able to achieve speed ups? What's your insight in this kind of, because normally companies do it bottom up, right? They take stuff from the open source. They don't have like a global authority on NLP in their ranks. So what do you find in this interaction? Is there a pattern? Do they generally do okay, or should we just all like turn to experts? Like are we all underperforming dramatically on our NLP stuff?
It is true that anybody, actually, I would love to hear questions from the audience too. So if you have a question after this one, just you can raise your hand. Maybe we can open it up. Also, make it exciting and answer your kinds of questions about AI and all the things, ethics, applications, and so on. But I think it's easy at this point to call yourself an AI startup or doing AI because you just download some TensorFlow code and run it and do some data pre-processing, and boom, you're like an AI startup. And in some cases, to be honest, if your application is just very straightforward and you're not trying to do anything novel, and that's never been done before, like self-driving cars or something like that, you can probably get quite far with the standard tools. And I love the fact that AI has become more and more accessible, and you can learn. I actually have a lot of folks who learn through the Stanford class that I've taught the last 4 years, and all the YouTube videos are online. You can basically go on like CS224 and.stanford.edu and learn. And that Stanford class really goes, and the videos go from like what's a word vector, how to represent a word in deep learning, all the way to like the latest research results. And so it's actually quite incredible how much you can learn these days, but then it is still a huge effort, and of course you need to know linear algebra and probability and statistics and Python and PyTorch hopefully, and probably TensorFlow still in a lot of places. So it's not like it's super easy, but it is actually, with the right amount of will and background and time investment, it's quite accessible these days. So we do have a large number of customers, though, who don't have the people who even know to go there and have the drive and will to do it. Right? We have like non-high-tech companies also that are our customers who don't have large multi-billion-dollar R&D budgets and things like that. And so we do give advice also to our developers and to our customers. And we usually, when it comes to AI, which I think is actually a reasonable strategy, we first start with packaged apps, where we just say, all right, if you just want to, understand your emails better, well, just use our standard email client, and we'll extract emails for you and suggest follow-ups and suggest calendar items and things like that. Or on social media, you want to know how to do social media listening, just like it comes with sentiment analysis, like Marketing Cloud, Social Studio. Or you want to find your company logo on all the things, tweeted images, then it's just like pre-trained on the majority of the top 5,000 or so company logos. So there are a bunch of things that just work out of the box. But then because we're a platform company, it actually becomes harder for us to do the next couple of steps, which is pretty much an enterprise software when you're not the customer because you're not giving up your data, but you pay a lot of money for that software. You have a lot of requirements, and the requirements usually are, I want to change. I want to change how this works, what kinds of inputs are given to this algorithm, and then people have custom fields and custom objects and custom workflows for their organizations and special company internal lingo and all of that. And so basically that leads us then to build a platform so they can do a lot of other things. And in AI in particular, that actually becomes quite tricky. So one of the products we've announced, I think last year, Dreamforce, or this year, was Einstein Builder, where you can basically predict one column from any other set of columns. And that sounds kind of boring, but it's basically 80% of machine learning and AI for enterprise companies. Like that column can be like, will this person pay their loan? Will this person pay their credit back on time? Should we give this person an insurance? Yes, no. Like there are a ton of different things in all kinds of verticals. Will this student finish college if you're a nonprofit? Should we send an email to this donor if you're some NGO? Like anything can be in this column, right? And you might want to start predicting it based on a set of all the other columns that you've kept track in your CRM. And so that feature is super powerful, but boy, it's also extremely complex because maybe people have like 5 rows and then they want to predict something, right? And they're like, oh, it's not working. I gave it these 5 examples, and so in some cases you have to say, okay, we just don't let you even train it. You need to have this minimum number of examples and rows to train. But then they're like, they select rows and select a feature that is essentially just a modification of the row you're trying to predict. So for instance, you might have one feature that is a dollar amount, and another feature that another column that is just like, if dollar amount is larger than this, put it into this bucket. And then and now you're trying to predict buckets, but you gave as input the original continuous value of the dollar amounts. In that case, you don't really need a classifier. It basically just maps that $1 amount to the bucket, and then machine learning is powerful enough to learn that. And so you have all these confounding factors and so on. So I could go on forever, but there's a lot of complexity when you allow non-experts to just, with a click interface, to train this. And in the worst case, it actually all works, but then it's kind of an unethical classifier. Like they added a race or gender column and then say, should this person get a loan? And now, because there weren't that many women in the 70s who started their own business to start a company and wanted a business loan, they're like, oh, that will not be successful, they'll not pay it back because we haven't seen it in training data, and then they don't give women loans to start a business. And so you have to have all kinds of ethical considerations. And again, because we don't have access to our customers' data, you can't just like say, oh, I look at it and I don't allow it. We can't look at customer data. So we have to train them also to have this ethical mindset and realize all the potential issues. And you might say, oh, we don't have a race column, so no problem for housing. But then maybe you have an income plus zip code, and the United States has tons of segregated cities, and then it still picks up the race from those 2 other columns. So there's a lot of complexity when you have this platform company that tries to really lower the bar for machine learning. That it's not even coders, but it's like complete non-experts who know how to build and administer an interface, but don't really go deep into the code.
Well, this is the first time I heard about that, and I think I find it fascinating because we hear about things like AutoML and like algorithmic approaches, but in your case, you have all the customer data, like you have a federated data, right? You have big data in terms of aggregation of a lot of medium size and small and large data, right? But now, because you have all this data, you can help them train better, but then you have to educate them, which is, I think it's a fascinating problem. It's a good problem to have.
It is, and it's one of the reasons I'm super excited to have. As part of our AI strategy, we actually have a Trailhead, which is a learning platform where you can go, and for this particular feature, we actually want to force, before you can turn it on, you have to take a Trailhead on ethical AI so that you're not accidentally building unethical AI systems.
Nice. So if you guys have questions, we have a few minutes. Please, maybe ask a question as loud as you can, and I'll repeat it for everybody else. Or we can bring you a mic. That's better. We have technology.
Love it.
I just wanted to continue the discussion on the ethical AI, and the question is, how do you detect machine bias in your systems? Because you do tell sometimes it's complicated, not just one column there. So, how do you enforce that?
So there's no silver bullet to this where like, oh, we just do this and then you're done. So for instance, like maybe it doesn't make sense to have a gender column for housing and loans, but if you're trying to find a new drug that deals particularly with pregnant women, it kind of made sense to like not, or you're trying to sell breastfeeding equipment or something, then it doesn't make sense to go sell it to men. And so that's okay. It's okay to have bias in that prediction system, right? And so you need to really educate people. And then, of course, there are some tools too that you can show people like these variables are very highly correlated with these outcomes. And I actually have to give Google some credit there. They have a lot of phenomenal tools to help understand your algorithms a little bit more. And depending on which algorithms you use, you can also immediately look at the weights. Like if you have a linear classifier and it's classifying for certain categories, you can look exactly at like this weight has a very high impact on being in this class, and you can help people that way. And then we know in some cases, like if there's gender and race in the database, that I think for the most part, I don't think we have race, but gender for sure, because there are certain products that you, again, want to market only or sell only to certain people. And so when we see high correlation with that column, then we can also give warnings. And then in general, for things where we don't have, because you can have free custom fields that we don't even know what they are, and they can be in different languages and whatnot. In those cases, we have to rely on the ethical training to help people understand it. So Kathy Baxter, who's on my team, we have a chief, or not chief, but an AI architect in the company, and she's on my team. She has this great quote, which is, ethics is a mindset, not a checklist, and that's kind of where we're also trying to go with this trailhead. Great question.
Hey, my question would be slightly more research-oriented, but I mean, over time we've seen the rate of innovation, especially in the NLP, maybe slow down a bit because maybe of popular adoption or whatever. But the leap from, let's say, nothing to anything to AlexNet to, let's say, ResNet, or transformers, or sequence to transformers to BERT, it feels as if it's slowing down. Is that true? And what would be an ideally next leap, do you think?
So I love that question, because you gave good examples of how it's not slowing down. Actually, like, things got so much better in NLP. If you've tried a translation system like maybe 5 years ago, it was just laughable. Like, you could not use it. Now the best translators in the world almost always use a machine translation system to do a raw translation, and then they just clean it up a little bit. Because, you know, there's some sort of common sense things that AI still can't have. And in some ways, NLP, I would call natural language processing, is sort of AI complete. Like, you need to know everything about the world and the visual world and common sense and reasoning and thought and all of that to really fully solve all of NLP. But in terms of real applications, like summarization, we've made a huge amount of progress in summarization. Basically, up until last year, when we published one of our summarization papers, there had not been a single paper that could generate multiple sentences and it would be kind of coherent. Even the best translation systems that you use in Google Translate, they just generate and translate one sentence at a time. And so that was kind of a big breakthrough. Now, BERT is another good example. It's another way to pre-train word vectors and basically use unsupervised text as your supervision signal by trying to predict the next word or the next sentence or words in a context. And that's a very simple idea that we've seen in a lot of other NLP word vector models and so on. But it's really powerful, and it turns out captures a lot of common sense reasoning too. And so, long story short, like, we've seen a lot of improvements. And yes, NLP, unlike vision for many years was in a state where everybody was publishing papers, but nothing really worked, right? And I'm like guilty of that too. I published vision papers back in the day and like graphical models and so on, and it was just like the accuracy, we had the state of the art from 33 to 37, and it was like not production ready, right? And then deep learning kind of on ImageNet, I think, had the first jump by like 20% or 15 or something, right, on the first version of ImageNet. But NLP is already a multi-billion-dollar industry. It was already kind of working reasonably well in search and in advertisement and made billions and billions of dollars, which is still not the case for computer vision. There's still fewer vision applications than NLP applications. And so, and again, NLP is even harder. It's, you know, in some ways, and there are lots of funky arguments you can make, but I would argue that language is kind of the most interesting manifestation of human intelligence. Like, a lot of animals have reasonably good visual intelligence too, but no other animal has such a complex language as we do. And so, long story short, I don't think we've hit a barrier yet. I do see a lot of improvements in NLP and deep learning, and I also think that the notion of deep learning has changed significantly. Now we often use reinforcement learning to fine-tune our deep learning systems in the end, to help different kind of loops that look at a global score that you wouldn't get at each word that you're trying to predict, but you have, for instance, roux scores in summarization or blue scores in translation, and you can use reinforcement learning to look at the entire text and then update your deep learning system. And deep learning systems aren't also just like layer of the same kind as you see in computer vision still a lot, but they have memory components, they have pointer components. Pointers are kind of underappreciated in deep learning for NLP, and I'm sorry if I'm boring people who are like not that deep into it, but like Pointers allow us to predict words we've never seen in training time. So the fact that in Squad, for instance, in question answering, you can give answers based on a question that you've never seen before, about a topic you've never seen before, and it still kind of gives you some right answers and generates words that it's never had seen in the training data. It's pretty incredible. Those are like kind of underappreciated advances in the last couple of years. And now what we're doing is, just in our group, we have this DECA NLP data set and first model where we have a single model that you can ask any kind of question and it still gives you a pretty accurate answer. So you can ask one model, what's the translation of this sentence into German? Who is the president of Zimbabwe? What's the summary of this document? What is the sentiment of this tweet? Like, the list goes on. There's even one fun, interesting example, which is like, what's the translation of this question into a SQL query? And so it learns to generate database queries. And it's all trained in a single model so that you can then combine different things, and that you can even do zero-shot classification where you can ask it a question that you've never asked before at training time. Like, Richard gave a keynote and nobody clapped. Is Richard happy or sad? And like, it learns to like point to the word sad based on that new context, even though it's never classified stories before. It didn't have a large amount of training data of happy and sad stories, and it just kind of figured out the concurrent statistics. So long story short, there's still a lot going on. The field of deep learning is growing, and I'm super excited for the future.
Thank you very much. I think this is all the time we had for questions. We need to get ready for the next panel. But thank you so much, Richard, for being here.
Thanks for coming, everybody.
Please stay where you are. We're going to have the panel now on data engineering for AI, and Richard is going to be on this panel. For you guys just coming in, you guys missed the secrets of deep learning. I'm very sorry for you, but you can catch them on the video which we'll have published. So let's give a big round of applause for Richard.
Thank you.
So yeah.